Find the exact value of each of the following expressions. So we got in part A, tangent 10 degrees minus sine over cosine 10 degrees. Note that 10 degree is not a standard angle. So we got standard angles like 0, 30, which is pi over 6, pi over 4, pi over 3, pi over 2, and their corresponding angles in second, third, fourth, etc. quadrants. Okay, so when we don't have standard angle, that means we are not going to use the value of that, like tangent 10 degrees from a unit circle. I mean, we can use a calculator, but that gives us decimal value, which is not good, so we are not going to use that. And if we look at closely in part A, we got a fraction sine over cosine. Oh, that's a reciprocal identity. So when we have sine of some angle over cosine of same angle, that is pretty much tangent of the angle. Okay, and if we do that in part A, this is tangent 10 degrees minus sine 10 over cosine 10 is tangent 10 degrees using this quotient identity. Now we got same thing, tangent 10 degrees minus tangent 10 degrees, same thing means we can cancel, so the value is 0. Okay, in part B, we got cosine square pi over 5 plus 1 over cosecant square pi over 5. Pi over 5 is not a standard angle. Okay, pi over 6, 30, pi over 4, 45, 60, 90, and their corresponding values, angles in other quadrants. So we need to use some identity here as well. I see 1 over cosecant. Okay, that's the reciprocal. We know that 1 over cosecant is sine. Okay, and then how about cosine? 1 over secant is cosine, and there's a tangent. Okay, I meant to write tangent. That's 1 over cotangent. Tangent is 1 over cotangent. These are three reciprocal identities. And this is also, if we have 1 over sine would be cosecant, 1 over cosine would be secant, 1 over tangent would be cotangent. So I got 1 over cosecant. This cosecant square is, this is just a shorthand. Whenever we have, let's say, cosine square theta, that is essentially cosine theta quantity square. This is the shorthand notation for this one. Okay, so this is 1 over cosecant, that angle square, you can think in that way. So part B, I want to write down 1 over cosecant, that will be sine, and see what happens. Okay, so this is cosine square pi over 5 plus this square is, we can put whole quantity square, 1 over cosecant pi over 5. 1 over cosecant of angle is sine of that angle. So that's the sine of pi over 5 square, and we write here. Okay, now we got cosine square angle plus sine square same angle. Okay, then we know the Pythagorean identities. Okay, what is that? Sine square theta, this is pretty much sine theta quantity square, plus cosine square theta, same angle, that will be 1. If we have cosine theta square plus sine theta square essentially, but we write in this way, sine square theta. So we have that situation here. Plus means we can swap the order, we can bring this to the front. So this is cosine square some angle plus sine square same angle. So it has to be same angle. Cosine square sine square means this is from this Pythagorean identity, that is just 1. So the value of part B is 1. Okay, so let me separate part B here. Let me copy part C over here. So I got in part C secant square 40 degrees minus tangent square 40 degrees. Note that 40 is not a standard angle. So we need to use some identity. Secant tangent. We know another Pythagorean identity. We know that 1 plus tangent square is secant square. And there's a third one. 1 plus cotangent square is cosecant square. Okay, there are 3 Pythagorean identities. That means a square. Okay. So secant square angle. Okay, look at now. I'm going to apply secant, and there is a tangent. Hopefully there will be something. Okay, secant square of this is, using this one, 1 plus tangent square of that angle, and minus we got tangent square of 40 degrees there. Now if we look at it closely, positive tangent square 40 minus tangent square 40 cancel. That means just 1 left over. Okay, that's that. Now let's do part D. Tangent 10, cosine, cosecant. Okay, again these are not a standard angle, so we'll use some identities. We know that tangent has, so we saw 2 of them, right? Tangent is 1 over cotangent, and tangent is cosine over sine. We have cosine here, so a lot of times when we are simplifying, it's better to use this one. This one is when we want to cancel and we have cotangent in the problem. Okay, this is rare. This is rarely used. But if you have 1 over cotangent, you need to convert it into tangent. And to simplify, we go by sine over cosine. So we can simplify this to tangent is sine, whatever angle is, over cosine of that angle. And we have cosine, that's good. Because sine, cosine, we want to keep that. Other trig identities, other trig functions, we want to convert them in terms of sine, cosine, so that we can simplify. So here is cosine 10, just leave there, times cosecant. Okay, so we wrote here, earlier I wrote here 1 over cosecant, 1 over cosecant is sine. Other way around, then 1 over sine would be cosecant. Okay, so cosecant is 1 over sine. Okay, now let's look at what we can do here. Oh, cosine 10 on the top, because when we have multiples, that's on the top, bottom cancel, and sine 10 on the top, on the bottom cancel. So it's times, so nothing left means 1. So that's the final answer for this.